Hey guys, Mr. Smith here. Just shooting a short mini lesson. Should take us maybe 10 minutes or so on histograms. And the reason I'm doing this is twofold. One, histograms will be a very valuable tool for us in our next unit on continuous probability distributions. And secondly, it actually can be useful for this unit too. It's just one more way to display data. And histograms especially can help you kind of visualize the shape of a distribution. And maybe you could even estimate some measures of central tendency. So in this mini lesson, I'm just going to talk about what a histogram is, show you guys how to make one by hand, give you guys some just tips, and then show you guys how to make one in Google Sheets. And there won't be any assignment or practice after this, just a short video tutorial. But please do follow along. Please do give it a go. I want to make sure you guys know how to make a histogram. So what is a histogram? It's a special form of bar graph. It's a glorified bar graph. The heights represent frequencies. Bars and histograms are connected, and this is the thing, they represent a continuous range of variables. So bar graph can be useful if you've got numerical data that you want to group into intervals. Histogram will be the one for you. Generally, we use bar graphs for discrete data. Histograms generally used for continuous data. So discrete data, maybe like scores on a like bowling scores or something, where you can only get certain bowling scores, right? Like 100, 101, 102. Continuous is more like, somebody's height. So somebody can be 150 centimeters tall, or 150.5, or 150.1, or 150.01. So generally, histograms are used for continuous data. To construct a histogram, very simply, we group the data into intervals. And sometimes you might see the word buckets instead of intervals, or bins. They mean the same thing. And I'm going to add a second note here. To group the data in intervals, you actually need to decide, well, what are my intervals going to be? How long are my intervals going to be? You must also decide on an interval length. And sometimes that is referred to as the bin width. It means the same thing. Once you do that, and I've given you an example of what some group data would look like. So we have, for some continuous data, we have 6 values in the 30s, 7 in the 40s, 9 in the 50s, and so on and so forth. And you can see the histogram is just those frequencies plotted as a bar graph with the bars touching. So I have a couple of things to add here. One is just to make sure, first note, you want to make sure that your intervals don't overlap. So the way we've taken care of that here, you'll notice we don't use 30 to 40. Like you don't copy this down, but using 30 to 40 and then 40 to 50, well, that would be overly confusing, because where would you put 40? It's unclear. So one way to handle that is to use like decimal values, just like 30 to 39.9 or 30 to 39.99, depending on how accurate or what accuracy your data is. Those of you guys who have taken some functions courses might be used to this information. So if you want to include 30, but exclude 40, you would do this 30 to 40, but with a square bracket on 30 and an open bracket on the 40. And then square bracket 40 to 50, but you use an open bracket on the 50. And that just means you're including the 40 in that interval. So that's another way. There's many ways. A lot of you guys will prefer just to use like 0.9. And ultimately, it doesn't matter, as long as you don't have any overlap. And another note, just make sure when you're drawing a histogram, because it represents continuous data, you want to make sure your bars touch. Make sure your bars touch. All right, so we're going to make one, But when you see some data, how do you decide on how many intervals to use? Because I've given you guys a visual. Look what happens when you use too many intervals. When you use too many intervals, you get kind of this like comb shape. Like everybody's like seen like a hair comb has like all those fine little teeth, and that's not very good because you lose sense of like the distribution. It gives you a comb shape, and you lose sense shape of the distribution. You don't want too many intervals because then you just get like, it's just like almost like information overload. But too few intervals, it just leads to not enough information. You can see just having too few, like one, it's like how that's not useful at all. That's just saying all like 32 values in this data set are between 30 and 90. Not very helpful at all. In general, this isn't like a set guideline by any like statistical society or anything, but in general, if you're making a histogram, around 10 gives you a nice idea of what the distribution looks like. So let's make one. Now we're going to make this one by hand, and then we're going to make it in Google Sheets. I'm going to show you guys how to do it in Google Sheets, and I have that data ready for you guys to go. But let's make it by hand first. So we're going to take this data, and we're going to group it into interval widths of 10. Makes sense for marks in a classroom. So we have the 90s, 80s, 70s, 60s, 50s, 40s. I think the lowest mark in there is in the 40s. Yeah, so we're going to do this. So for our interval, I personally like this notation. So we're going to go from 40 to 50 and use a closed bracket when we want to include the number. So for the 50s, we'll say 50 to 60. Open bracket on the 60s, so we're not including it. And then we're in the 60s. We're in the 70s. We're in the 80s, 90, and then we're in the 90s, 90 to 100. Now, with 100, this is the highest possible value. There's no chance at having an overlap, so you can put a square bracket if you'd like for that last one. Generally, when I have my students make a histogram, I'll give a column in case you like making a tally, like as you're counting, like if you like making a tally like that, then you could do that if you wanted to. That's all that column's for. Don't use it if you don't want to. But basically, we've got to count out like how many values are in each of these intervals. So if I'm doing it by hand, generally I like to cross off values as I go. So I can see there's one number in the 40s. So 1 for that frequency. How about numbers in the 50s? 1, 2, I think that's it. In the 60s, 1, 2, 3, 4, 5. I'll talk about a little self-check afterwards. In the 70s, 1, 2, 3, 4, 5, 6, and 7. In the 80s, 1, 2, 3, 4, 5. In the 90s, 1, 2, 3, 4. Everything's crossed off. And I'll just do a little double check here. Now, actually, I have a sense that I missed one. I missed the 94 right there. Because I was adding them up in my head, and I'm like, that's not giving me 25. But that's a self-check. Add up the frequencies, 3, 8, 15, 20, 25. And you should get 25 because you should be representing all the data, right? So now we're ready to make our histogram. When you make a histogram, it should have a title. Actually, we'll give it a more appropriate one. Just have just a nice boring grades. That is just awful printing. My tablet's not behaving too well right now. That's okay. You know what? I can use the text tool if I wanted to. Frequency would be in the vertical column. So I'm just going to put frequency with a little dot. And on the bottom, we're just actually plotting the grade values. And we don't need to go too high for our frequencies. 1, 2, a scale, just every square is 1 would work just perfectly because our highest frequency is 7, but you can change that scale if you need to. And let's do it. So we need a bar for the 40 to 50 when we only have 1. So we make a bar that's just 1 unit high. and just continue. 50 to 60, make sure the bars touch. 2 units high. 60 to 70. 5 units high. 70 to 80 is 7. And then 80 to 90. 90 to 100. There we go. So now that I've drawn this distribution, I can see that this is what we call a negatively skewed distribution, where it's not quite symmetric. There's like more of a tail on the end. This happens when you have kind of outliers in the lower end. You can see that most of this class did pretty good. But there's a few in the 40s and 50s that kind of are just dragging the distribution backwards a little bit. But yeah, that's kind of hard to picture just looking at those 25 values. So, but making a histogram, you can just get a sense of how the data is distributed. So it can be very worthwhile. Now that was all well and good for 25 values, but what if you had a big spreadsheet? What if you had hundreds of values, thousands of values, 10,000s of values? Making a graph by hand, obviously very impractical. So I'm going to show you now in Google Sheets how we can do that. And the risk of, I'm just going to head over to Google Sheets actually. A tab open, but I'm shooting a video. I don't want to risk losing the shooting I've already done. Histogram data, perfect. Already made this one earlier. All right, now I've got the same data you guys are doing, and I've shared this link with you guys. So if you want to make your own, you should be able to open this up, make a copy, and just make your own histogram. But I just copied that data into one column instead of in a 5x5 grid. So it's the same data. Let's do this by hand. How do we do it? Pretty simple. You just highlight all your data. And we're going to insert the chart. So insert chart. Now, the default, did that at the top there. The default for me here was to make a line graph. I don't want a line graph. I want a histogram. So depending on, I'm not sure whether, if you've done a lot and maybe Google Sheets kind of tracks like what your preferred type of chart is. We might all get a line chart. We might not, but we don't want a line chart. We want a histogram. So we're just going to check the drop-down menu and just go down and select histogram chart. Now, this has the same kind of shape, but as you can see, look at the interval widths. They're 40 to 52, 52 to 64. These are interval widths of 12. We don't want that. We want interval widths of 10. So I'm just going to show you guys how we can customize our histogram. Pretty easy. Let's go to customize. Let's select histogram. And we don't want the bucket size to be automatic. We want to make it 10. So change it to 10. And now you can see we actually have the same histogram we had before. Done. You can change the titles. That fancy histogram title. You can put titles on your axes. So grades, I'll put on the bottom where I had grade values on the one I did by hand. Maybe we could add one in the vertical, just in case you want to put your best forward if you're making a graph summarizing for data for a project or at your job or something. And there we go. We've made a histogram, and this didn't take us very long. In fact, it would take us the same amount of time for 25 values as 25,000 values. But I do want you guys to know how to make a histogram. Hopefully that tutorial helped you. And moving forward, when we need to make a histogram to visualize some data or to see how data is distributed, we'll be able to do that. All right, guys, that's it for me for this mini lesson. Hope you have a great day, and we'll see you soon.